So all of this leads us to a very important concept in this chapter called a factorial. Guys, called a factorial. Okay, and factorials are used when you want to take n objects and figure out the number of ways to order those objects without any restrictions beyond that. So that would be like the 10 kids in a line. How many ways can you arrange 10 kids in a line? We said it was 10 times 9 times 8 times 7 times 6, blah, 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 all the way to 1. That's a factorial. That would be 10 factorial. Okay? So n factorial is just basically going your first number times that number minus 1, right? So it would be 10 times 10 minus 1, which is 9, times the number you started with, minus 2, which would give you 8, right? And so on until you get down to 1. Okay? So 10 factorial is a shortened way of writing like 10 times 9 times 8 times 7 times 6 times 4, blah, 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 blah. Okay? Or n factorial for short. Okay.
Isn't that longer?
What's that? This? That's shorter than that. So instead of writing all of this, you can just write 10 factorial. You get the same thing. In fact, sorry. Yeah, so to do it in your calculator,
10 exclamation mark?
10 exclamation mark. That exclamation mark means factorial. So if you go in your calculator and you press, well, write 10 first.
Oh man, it works!
You write 10, and then press math. I'll write this down on the screen here. So do factorial, say 10 factorial, you press 10, and then you press math, and then go PRB. So I usually just press left.
Oh man, the question mark doesn't mean anything.
Oh my land.
PRB.
Oh, mine says probe.
Okay?
Yeah, it's PROB.
Or PROB, whatever. That means probability. And then you can see, I think it's option number 4, is the factorial sign.
So that's my factorial.
Okay, so that's how you do a factorial. Rather than multiplying all of those numbers in your calculator, you can just do the factorial and it saves you a lot of time. So, this also leads to the idea of a permutation. This is an important word. Make sure you get this. A permutation, yeah, that's where I got it. Guys, a permutation is an arrangement of objects. So when I ask you, how many ways can you arrange the 10 people in a line? That's the same thing as asking how many permutations are there for 10 people in a line. Okay, it's the number of ways you can arrange things. Alright, in order from one end to another. So, if we had 3 people, we'll call them Alice, Bob, and Charles, and you wanted to stand them in a row, how many different arrangements or permutations can you have? Well, here are the options, so I wrote them out for you. Okay, you could have Alice, Bob, Charles, or ABC, ACB, BAC, BCA, CBA, CAB.
CBC.
Or, how many ways is that in total? 6. Or, 3 for the first position, 2 for the second position, 1 for the last position, or just 3 factorial, which is 6. Okay? So, these arrangements or these orderings again are called permutations. One super important thing, don't miss this. Because if you miss this, you will be screwed for the rest of the chapter. Okay? One super important thing to remember with permutations is that when you're using permutations, the order of the things matters. That's really important. Okay? If the order of the things that are being arranged matters, you use permutations. You'll learn about something next day called combinations, where order does not matter. To give you an example, say you're being dealt a 5-card hand out of 52 cards, deck of 52 cards. How many different decks could you be given? Or, sorry, no, decks, hands. Well, the order in which those cards are handed to you doesn't matter. Right? If you get ace, 1, 2, 3, 4 of spades, that's the same thing as getting 4 of spades and then ace of spades and then 2, 3, right? The order in which you get those cards doesn't matter.
Alright.
Okay?
Okay.
So, is that making sense? If the order in which you arrange things matters, you use permutations. If it doesn't matter, you use something called combinations. You'll learn about that tomorrow.
Yes.
Okay, good. One of the most fascinating permutations I've ever heard of is the number of ways you can arrange 52 deck of cards. Okay, and have I showed you guys this video? I think I've showed most of you this video. Okay, it gives an unbelievable result. I think it's completely unbelievable. If you had 52 cards and you wanted to arrange them in a particular order, all 52 cards, how many different ways can you do that? Those of you who haven't seen the video, have you all seen the video? Okay, those of you who haven't seen the video, how many ways do you think you can arrange 52 cards?
Well, just give me a second.
Take a guess.
550,900.
Give me a more exact guess. If you know the answer, don't spoil it. Just make an estimate.
8 billion.
8 billion.
800 trillion.
800 trillion.
A lot.
So this, I'll just show you. And if you're watching on YouTube, I put a link in the description. So, moving on to permutation notation. Okay, this is important. So we use a special notation for permutations to help describe the number of ways of ordering n things into r positions. Okay, and this is based on the idea that the number of positions that you have for your objects is not always equal to the number of objects that you have. For example, let's say you had 10 dudes at a high school dance. All of them are single and did not have a date. Bummer. But they came to the dance anyways, because I guess that's what you do when you don't want to look like a total nerd. You go to the dance without a date, rather than stay home. Whatever, they're there.
Tom's flying out of the limo.
Okay? They're there. Yeah. These 10 guys are at, maybe their dates ditched them, to make it sound more pathetic. Anyways, the teachers who, set up the dance didn't think that there would be that many people who didn't have dates. So they only put 4 chairs up against the back wall. Okay? Only 4 chairs up against the back wall. How many ways can those 10 guys sit in those 4 chairs?
The same as the 4-digit password.
This would be it would be the exact same as the 4-digit password, right? So you got 4 chairs. 1, 2, 3, 4. Any 10 of those guys can sit in the first chair. 1 guy sits down, you've only got 9 guys left. 2 guys are seated, so there's only 8 for the third chair, and then 7 for the last one. And how much did that give us again? 5,040? Okay, so 5,040 ways, and so those 10 guys stand there and talk about all the different arrangements that could be made by sitting in those 4 chairs, and that's probably why they don't have dates yet, because women love smart people. You can also do this using factorial notation. Or sorry, not factorial notation. Permutation notation. Here's how that works. Okay? Yeah, I just showed you it. Okay, permutation notation. So, here's a general formula for permutation notation, and it works like this. NPR, this would mean the number of things you have and the number of positions for those things. So in our case, the number of things that we have is 10, and the number of positions for those things would be 4. Okay? Calculating that using the formula, that would be 10 factorial divided by 10 minus 4 factorial. Okay? I'm going to expand that out. It'll be a little bit of writing.
Why would that work, though?
It's going to be a little bit of writing, but here's maybe why it works. Maybe this will help. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. Blah. Okay? Divided by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. That's writing it all out longhand. Right? But I'm doing that for a purpose, because this chunk right here gets divided out. And in context of our problem, that's very useful because this top factorial is assuming you have 10 chairs. So to ignore the fact that you only have 4 chairs, you divide out that last 6 factorial.
Okay, that makes sense.
Okay? And you'll notice that this multiplication right here is what we did above, right? Just right here. Okay, so intuitively we could figure it out, but this is how you would use the formula. It will equal the same thing.
Wait, you skipped 5. Did you mean to skip 5?
No, I didn't. There should be a 5 in here. Times 5. But anyways, this gets cancelled, so you're only left with what we had multiplied beforehand. So this still equals 5,040.
So it's a longer way of doing it.
If you read it all out like that.
That's the mathematics in scientific way.
But this is useful for putting n things in r positions. Okay? Just take the number of things and divide it by the number of positions, factorial for both of them, and you'll get your answer.